Oh yeah, now I can. Okay. Yeah, now I think it's gonna work. Let's see.
Okay, it's fine. We can see it now.
Yeah. Okay.
Great.
Are the slides moving?
Yeah. Yes, great.
Yeah. Okay. Good. So let's try that. So thank you again for the introduction. So I'm gonna talk about this biotechnology, is how we can use this tool more specifically for gene editing for animal production to face the challenges we face here and in your case here. So I will start saying that biotechnology has been among us for a long time. We know that we have been using the yeast to make bread, wine, and beer production. So biotechnology is part of our life since the beginning of civilization. In the last century, we have been using artificial insemination, embryo transfer, in vitro fertilizations, as the professor said. The last 20 years, sex-sorted sperm, the cloning, animal cloning, all those reproductive biotechnologies has contributed to increase the genetic gain. One example is here in Brazil, we have been producing a lot of in vitro fertilized embryos from different breeds, from European breeds and Zebu breeds, the Indian breeds that was brought to Brazil 100 years ago. So those technologies has been very useful for us for our genetic improvement program here in different breeds. But here today I want to talk about what we call the modern biotechnology. But more specifically for genome editing, the professor has already mentioned some examples of how to use the genome editing. So I will also give you 3 examples to put this in a context, and then I will tell you how our proposal here to use the genome editing for our breeding programs. But before starting, just saying that the genome editing, you have different tools to perform this the gene editing. So we have here in the picture on the right side, you have 3 examples here: the zinc finger nuclease, the tannins, and the CRISPR-Cas9. So they work in this similar way. So you have an enzyme, a nuclease that breaks the the DNA, the gene, and when the gene is repaired, you can insert a mutation to knock out a gene, for example, as you mentioned before. But you can also use this to correct a gene that is defective gene. You can correct this problem, or you can insert a new gene, for instance, to make a transgenic animal, for instance. So you can use this genome editing to manipulate the gene, even without make a transgenic animal. So you have these options. So in crops, we can find a lot of studies using genome editors. So they in crops they call these genome editors part of what they say is new breeding technologies. So they have used those NEBTs, including genome editors, to accelerate the genetic improvement and also to develop new traits in plants. And actually, there is several examples of crops and yeast in the pipeline. Some of them are already approved. Others are near to be approved. We find these examples in the US. Even here in Brazil, there's yeasts, for instance, for alcohol production and also crops. Well, we can use the genome editing in farm animals in similar way of people have been using in crops to improve the breeds, in your case here in animals. We can use this to increase the resistance to disease or parasites, to improve livestock production, and also to improve animal welfare. This is a little bit different from crops, but we can use this also for improve animal welfare. So I will give, as I said, I will give you 3 examples. Before doing that, just show you that the examples are from different parts of the world. We can find genome edited livestock in several countries. All of them were made only for research proposal. So there's some of them actually Actually, there is one of them that's already proved for market in Brazil and Argentina. I will give you this example in the end of my presentation. But we can find animals, genome edited animals in Australia, New Zealand, China, some countries of Europe, US, Canada, in Brazil, Uruguay, and Argentina. But as I said, most of them with research purpose. So I will show you those three examples. So one of them is one of them is related to knockout gene. So you can use to improve the meat quality using genome editors. So for that, one thing that you can do is to knock out the myostatin gene. So this the protein of this gene retain the muscle growth. And there are some breeds like that one in the left side, in the top of the left side, the Belgian blue. Some breeds that has they have this. I'm sorry, they have a mutation on the myostatin gene. So that mutation causes a lot of function. So the animals has muscle hypertrophy, what we call a double muscle. So some groups in the US and in Uruguay, they use the genome editors, Talens, and also CRISPR to knock out the genes. So if you look in the picture, on the right side, we have an Nelore one. This is a Zebu beef breed with the knockout of this gene. And in the bottom of the right side, I'm sorry, is moving without asking. So you can see also the sheep here. So this is one example to knock out the gene, the myostatin gene, to improve the meat quality, right? So usually those animals, the Belgian blue breed, for instance, they have a better quality of the meat. You can also use the genome editors to increase disease resistance. So one example is one use of that to avoid these diseases, the porcine reproductive and respiratory syndrome. So this syndrome causes reproductive failures and pneumonia in pigs. It's endemic in the US, in Europe, and Asia. What two different groups, one in US, another one in UK, they knock out the one gene, the DC. I'm sorry, I have to fix this. They knock out the gene, the CD163 gene. The gene is a receptor for the virus. When they knock out the gene, they avoid the gene to enter the cells. In doing that, they were able to avoid the disease in those pigs. So this one interesting thing, just one mutation and a receptor, and then there was no disease in those pigs. And the third last example is to use genome editors to increase the heat tolerance. This is a very important issue for us here in Brazil because we are in an environment that is very hot and high humidity. So there's some breeds that were brought to Central and South America in the beginning of the colonization. Those breeds adapt to our environment, but they are not the performance of production is not very high, actually it's low, but they are very adapted to our environment. Those animals have a mutation on prolactin receptor. Well, I'm sorry, there's something wrong here. Can you hear me? I cannot. There's something wrong with my screen. I cannot control it. Well, I think something wrong with my computer. I don't know why I cannot control. Well, that's strange. It's weird. Let's see what I can do here. Well, I'm really, really sorry. I don't know what's going on. My computer is stopping this screen. I cannot move it. I think I have to turn off my computer.
Okay, it's moving now. It's fine.
Yeah, but I have to. Let me see. I can start this again. Oh, I'm sorry. So I have to do this again. So first of all, we have to I think that's something in the settings. Let's see. Can you see this now?
It's fine.
Oh, let me. Okay, good. So, yeah. So I was talking about the heat tolerance, right? Yeah. Okay. So yeah. So those breeds they have these mutations, the prolactin receptor gene. Those mutations is associated to a phenotype where those animals have a smooth coat and short hair. So we call this sleek hair. That's what we can see here in the picture on the left side. An animal with this smooth coat and short hair. When compared to the hosted one, you have a long hair. So what people have been done is to move that specific mutation found in those Iberian breeds adapted to South and Central America, move this mutation to breeds that are thermosensitive, like the Holstein or Angus. So that was performed in US and also here in Brazil by a company, the Aceligene company. The picture here, we can see this picture with the cloning calf with this mutation. So this is the third example of using genome editors for cattle. So now I want to again. Let's see. That is weird. Okay, good. Let's see if it's gonna work now. So I want to talk about our condition, our proposals here. So as I said, most of the Brazil land is the tropical belt. So we have several challenges here. But we also have a large herd, the second large herd. So so you have to face all those problems to raise those animals here in Brazil. So those challenges involve the high temperature, the humidity. So you have the heat stress problem. We have a problem with tropical disease. Tick-borne diseases are very big concern here. We also have some concerns about the quality of our tropical forage. Despite they grow very fast, they also lose the quality very fast. So what we are start doing here is to use genome editors to increase the term tolerance in this European cattle. So similar as I showed you before, we have here the Caracu breed. This is a breed that was brought to from Portugal to Brazil in the beginning of the colonization. Those animals also have this sleek allele, the mutation, the prolactin receptor. So what we started doing here is to move that mutation from found in this Caracu breed to Holstein and Angus cattle. So instead of crossing Caracu with Holstein, you have the F1 and F2. So we moved only the mutations we wanted to the Holstein one. We also started doing some research here. We found some genomic regions in the Gyr cattle. Gyr is an Indian breed that was brought to Brazil about 100 years ago. So we found some genomic regions. In those genomic regions, we found some genes. And now we are trying to find some mutual mutations. They are in charge with those thermotolerance response of this cattle. So we plan in the future to move those mutations also to Holstein and Angus and other beef cattle. So we want to use this for our breeding program. On the other side, we also want to use genome editors to increase the milk yield and zebu dairy cattle. So as I said, in the right side, we have here the Gyr cow. So it's very adapted to our environment here, to the high humidity and temperature. But the performance in milk production, despite we have a breeding program that has been seen in the last 10 years, 20 years, 30 years, the milk performance is still low of the Gyr cattle. So what we want to do is to move alleles that were associated to milk production in Holstein and Jersey cattle, and move those alleles to Gyr cattle. So again, instead of crossing Holstein with Girolando, actually we have a breed of that. We call it the Girolando cattle. So it's a crossbred. We have the F1, the 3/4, 7, 8. But now instead of crossing Holstein with Gyr, we want to move only the mutations that are associated with milk production. So here I have an example with the GET1. We have the allele A. The allele A is associated to milk production, but the frequency of this allele already exists in Gir cattle, but the frequency is very low. It's only 4%. When you compare with host and Brazilian host, it's 73%. So what we want here is to increase the frequency of this allele in Gir cattle. And maybe with that, we can also increase the milk production, maybe in 10 or 15% in Gir cattle, without crossing Gir and Holstein cattle. This is our short, medium term goal using the genome editors in our breeding program. But we also have the long term here, is to incorporate the genome editing in our breeding program. So here we have again the Gir cattle. In this graph, you can look at the evolution of milk production in Gir when we started our breeding program in 1988. So the cows produce around 2,000 kilos per lactation, and now in 2018 they are producing almost 5,000 kilos per lactation. But when you compare this with Holstein, and for instance, this is too low. So you want to use the genome editing to speed up, to accelerate these genetic features for milk production, and not only milk, but also for protein. So what you want here is, this is a long-term goal again, is to identify the quantitative trait nucleotides. So the nucleotides, they are the SNPs, right? The single polymorphisms that affect the quantitative traits, some specific quantitative traits. Once we identify those KTNs, we need to be able to edit all those KTNs in the genome. And with that incorporated then in our breeding program. So in that case, think that we are not put another breed here, but trying to find the KTN, the SNPs, they are associated with a specific trait, and then edit those SNPs in a large amount of embryos, so that you can have this in just few generations. There is a simulation that was performed by Rhodes Institute 6 years ago, when they did a simulation editing 20 KTNs, 20 SNPs, and 25 bulls, plus genomic selection. So when they did that, they found that doing that, it would be possible to double the cumulative response to selection in 20 generations. That's what we can see in the graph on the right side. The blue line is genome selection only. So, and the black line and the top is genome selection plus 20 edits. So you can double the cumulative response to selection. So for instance, in your Gir breeding program here, we use the progeny test plus genome selection. So now what we want now in a long-term goal is to use progeny test, genome selection together with genome editing. Well, one thing that we can ask, but once you have those animals, genome edited animals, can we breed those animals without any concern? What are the risks with that, right? And can we, how we can to regulate those animals? I can say that depending where you are, you can have a more strict or less strict regulation, or even in some countries that doesn't have regulation yet, right? So I can give you the example here in Brazil. In Brazil, we have our Biosafety National Committee, it's CTN Bio. They have a normative resolution, this was in 2018, when they say that a product can be registered as no GMO. So, so it's exempt of regulation by the Biosafety National Committee if this GMO has no recombinant DNA or RNA. I mean, there is no foreign DNA in those genome edited animals. So that means that you can knock out a gene to induce a lack of function, like the myostatin gene that already exists in some breeds, but not in other breeds. Even some SNP that exists in some Holstein breeds, we were not able to find in Gear one, right? So in that case, those animals will not be considered GMO. So, for instance, genetic elements or alleles that already exist in some species, which could be obtained by crossbreeding, for instance. This is the same case again, Holstein in Gear. So if you have some mutations that are associated with some trait in Holstein, you can move them to Gear and vice versa, without considering then genome editing, I mean GMO animal. But this is case by case analysis. I will give you the example of tilapia fish. So there's the tilapia fish, the genome edited tilapia fish was produced by the company, Aqua Bounty company. This gene has a mutation, a knockout of myostatin gene, the same gene I mentioned earlier. So, so it's just a knockout of the myostatin gene. So there is no recombinant DNA or RNA in the genome of those fishes. So because of that, it was considered here in Brazil, also in Argentina, as no GMO. So they are exempt of regulation by CTN Bio. So of course they have to be regulated by other agencies, but not by the CTN Bio. That's the biosafety agency in Brazil. So that's a good thing for us when you think that now you can use this tool to accelerate the genetic improvement. You can use it without making a transgenic animal, right? Without insert any foreign DNA, but now we can potentialize the use of this tool to improve the animal production and then to face the challenges we have here. We have here in Brazil, in tropical and subtropical environment. So to finalize that, just to say that we believe that genome editing will be very useful to overcome the challenges we face in our current livestock production system. So we can use this to increase the animal production without pressure, or reducing the pressure on the use of land. This is very important here when we think in Amazon, for instance. A lot of people complain about using cattle in the board of the Amazon. So, and actually we don't need that. But what we need is, instead of using that kind of land, we need to increase the production. We already have a lot of land with cattle, but we need to increase the production of those cattle in our conditions here. And with that, we can benefit farmers, we can benefit consumers, and we can benefit the environment too. But we still have to deal with the regulatory aspects of genome editing. Some countries don't have this regulatory aspects established, so they need to establish that. But more than that, those regulations need to be agreed among countries, so that all of them can benefit of the use of this tool. But of course, we have to keep this to keep in mind that we always have some ethical issues that have to be considered. So it's not only make genome edited animals, but you have to check if the gene or if the mutation you want has other implications than that you target, right? So this is one thing that we have to keep in mind. And finally, just to thank the foundation that have helped me here in Brazil, the CNPq, the FAPMIG, and CAPES, and all those people that helped me here also in the lab here and also in US. So thank you very much. Muito obrigado. I'm open to questions.
Thank you, Prof. Once again, a beautiful round of applause for the Prof. He's been at his laboratory doing a lot of work, coordinating research, and doing research himself. And so do we have any questions? But please let us, first of all, while we jot down the questions in a piece of paper, and then we can now get our hands raised and have the questions physically. So, yes, let me take your questions. But then you will still write down for me, sir, because of the secretary.
Thank you, Prof. Are you listening to us? Yeah. Is it online?
Prof, are you there?
Yeah.
Congratulations with the paper. When you are doing gene editing, in a country like Nigeria, where I have a lot of tropical diseases, and you are editing for improvement, let's say for beef and terms of growth rate or meat production. In the same pattern, as you are increasing those traits, you also find out that some of these animals won't be able to withstand some of our conditions here in Nigeria. Now, when you are doing this editing, how do you control those other parameters that can affect these animals vis-a-vis the health of the animals? Thank you.
So,
You jot down your thoughts?
Yes, I will. Did you get me right?
Prof, you want to take on that question? Please, can we have it on board?
so do you want to make another question?
No, please answer that.
Okay, so let's see if, so my opinion about using genome editing in Nigeria, I think that's the first question, right?
Yes.
Yeah, in cattle, yeah. I can say that I think when you look at the map, you have maybe it's the same conditions we have here in Brazil. Maybe maybe the breeders have different conditions, but the environment is the same. So I think we may have some concerns. But in your case, when you think in cattle, for instance, you have a biodiversity in cattle, different breeds that you have to keep then. So, but you have also farmers that need to produce, right? Maybe you don't have small holders, so they maybe not possible to then have maybe genome editing animals in the beginning. But once you develop this for some specific breeds that you think is useful for you, not for all breeds, but it can be useful for some of the breeds. And once you have a herd, enough animals for that, you can also use those animals for smallholders. And but you have to keep in mind that is despite we have the same environment. The strategy to produce food is a little bit different. Here we have producers that have our small producer here is about 20 cows, right? 25 cows. I don't know exactly in Nigeria, but I know that in Kenya it's about 5-10 cows. So it is a little bit different. So I have just keep in mind that you have difference when we compare to Brazil in terms of the breeders.
Okay.
I don't know if you okay.
It's all right. Yes. Thank you.
Do we have another question?
I will.
You're still writing your question. Okay. Please switch on your mic.
What's his name?
Yes, Prof. Thank you for a wonderful presentation. For us here in Nigeria particularly, gene editing is a new technology. It's quite new to us. So we would like to ask, how do we collaborate to be able to acquire this technology, especially for our young scientists, especially in a situation where we will have our institutions being ready to sponsor young scientists from their organizations to be able to acquire this technology. So we would like to know if it's possible for our scientists to acquire this new technology and the experience that you have in utilizing gene editing in improving animals.
Okay. Thank you for the question.
Over to you, Prof.
Yeah. So yeah, I think we are also starting with that. We started just 2 years ago, so we are new on that too. So I think we can learn together. But our corporation here in Embrapa, I know you should know Embrapa, we is very open to collaboration. One thing that we can do is also trying to have a kind of collaboration where we can receive people from Nigeria or even other countries nearby around you, and also send people to you. But I think this is one thing that can be done easily because Embrapa has interest in developing the technology for cattle, and so we can do this together, right? So we can start together doing this. I think this is easy to do. Just one way to. First of all, I think you have to contact the right person here in Embrapa. I am in a dairy cattle station unity, but you can contact people. I can put someone of you in contact with our headquarters in Brasilia, and we even here in the dairy unity, and so that we can have this kind of start doing this kind of discussion to have this kind of collaboration. But we're very open to receive people and also to send someone to your country.
Thank you.
Thank you, Prof.
Yes. Can I
Please.
I would like to ask a question.
Okay, please, sir. Please go ahead. Your microphone.
Hello, Prof. Good afternoon. This is Nigeria. Good afternoon. This is Professor Major here. I would want to ask one or two technical questions. We've seen your slides. Are you hearing me?
Yeah.
Are you hearing me?
Yeah, I can hear you.
Okay. Now, we have looked at your slides and very interesting and revealing. And I thank God that Brazil is right there on the biotechnology. But I want to ask, you people at Embrapa, do you have the facilities and the technology? You have the technology and the facilities. How do you think that you can sustain these facilities over time in Brazil? Number two, the animals you showed us with double muzzle and so on, with enlarged back fat and so on and so forth. Are they breeding animals or are just meant for meat only? They are slaughtered. If they can be turned into breeding stock, have you tested the heritability and the interaction with the environment? Because in Nigeria Nigeria has a vast climatic environment, just like Brazil. Have you been able to expose these animals, put them to test for quantitative performance? Because some of them, as we know in utility crosses, they are just terminal crosses, which they can just be used for slaughtering. But we are a developing country, and we need to have such quality animals that we can use to breed, to improve other livestock. So what are you doing with these animals? Is it just for slaughter? If not for slaughter, you are using for, if you want, intend to use them for as a breeding stock, have you tested the ability to pass on those genes to the next generation? Thank you very much.
Oh, thank you for the question. Yeah, good morning from Brazil. Yeah. Let's see. The first question is about how we keep our lab here. Is that?
Yes, and the facilities do you plan to sustain over time? Because the problem in Nigeria, we can't even buy the equipment But after 2 or 3 years, you go for spare parts that have already moved ahead and you can't even see the spare parts that will match the particular one. Does Brazil have the facilities to sustain their facilities? The money, can they sustain their facilities by changing the spare parts, updating their facilities? We can't do so in Nigeria easily.
Yeah, we have some issues similar to yours in terms of you have some products that has to be imported, some reagents, for instance, in the laboratory. So sometimes it takes 30 days, 6 days to be delivered. So we are not very how can I say, if you are to compare, if you are in Europe or EU or United States, for instance, if you buy a reagent, you can receive it the next day. Here in Brazil, we will receive it in the next 30 days, between 30 and 60 days. So we have to plan a lot of ahead of this stuff here. But we have facilities. Our facilities here was established. In our case here, for instance, was established 20 years ago, but not for genome editing, but genome editing use the same facility we use for in vitro fertilization. So we have starting work with in vitro fertilization, animal cloning in the 90s. So we built our facility year by year. So now we have this ready to use. We have micromanipulators. We have established a new condition to generate genome editing also without micromanipulators. So that's one reason we have the facility here. Some universities in Brazil also they also have this facility because of the in vitro fertilization technology. So when they starting research, when they were
second question.
And about the second question, the myostatin call.
Yes.
I gave you an example because that was generated in the US and in the case of call, right? In Uruguay, in the case of sheep. But here in Brazil, for us, it's not. We have not worked with this myostatin knockout, and here in Brazil, for us, this is not. It's not a good target because those animals have some. In case of cattle, they have some. Some of them have problem in the parturition, in the delivery.
So we're on the same page, you know.
Yeah, but in that case, yeah. So it's so for us, we don't have this kind of problem, you know. We already have we have other we are focused on other targets, not the myostatin. So I give you an example because it was generated by other countries, US and Uruguay. Yes. But this is one thing that's I agree with you. This is one thing that is for our conditions is not a good one.
Yeah. My worry is that you as a geneticist, you have an impression of what these animals will turn to. If you want to use them as breeding stock, do they have a future? Have they been tested? That's the question.
Yeah. So you know, there is you know the Nelore breed, the Nelore one, the white beef cow here. There is some of them they had this kind of mutation, but it's fixed in this in some lines of Nelore cattle here. So they are able to keep those animals, but they are not. How can I say that? In that case, the myostatin gene is not very spread in those specific lines of cattle. They also want to keep those animals, but you know they don't have other breeders want to buy those animals because of this. What you said.
Okay.
Okay, thank you, Prof. Do we have another question?
Yes.
Please, go ahead. Come to the mic.
They go to the laboratory, they manufacture these animals, cannot put them into the field. Yes, they just time. So it cannot help it. They can't be sustained. Cannot give it out for farmers.
All right, my name is Odiakwa Chijindum Victory. I want to know the cost effectiveness of this technology, looking at it from the business point of view. When you want to start by setting up the lab, the cost of setting up the lab, is there profit for a businessman to adopt this technology? Thank you.
There's no profit in research.
Nigeria.
There's no profit in research.
That's my sister.
Yeah, because what we look at, the end point of what we are looking at is to make money. We want to put food on everybody's table. The businessman wants to make money from his business. An ordinary man wants to get food at a very cheap rate. You make it available and affordable. So now, this technology is, looking at it from my little idea, I know it's expensive to set up this lab and to maintain it, because you have to maintain it to let it work. So how do we come in?
Okay. Is it a good business model, or is it just some scientific experiment that works best in the lab? Is it viable as a business? That's what we're talking about. Prof, you want to answer the question?
Yeah, I can mention the. I can make some comments about that. It is. I think this is important when you think this is profitable or not, right? So it's not only produce food, but for companies, they need to be the business needs to be profitable. I can give you the example in Brazil. As I said, we use the same facility for in vitro fertilization. So if you want to produce those embryos, those animals, you need to produce those embryos. The IVF facility already exists. So we have this in different private companies, private laboratories. They can manipulate those embryos. Maybe the
answer this woman.
Can you hear me? Yeah.
Please go ahead, Prof.
Okay. So maybe yeah. The big cost city would be to establish a new lab. I think that would be a cost, but that lab doesn't need to work only with genome edited animals. They can work with in vitro fertilization. They can work in breeding programs, doing another producing embryos from specific high merit cows and bulls, and then you can use for genome edited too. So you can dilute the cost of keeping those facility, not only for genome editing. You have the issues with royalties. You have the companies who developed those tools. So maybe you have to discuss with them the use of those or some of those technologies, right? Like the CRISPR one. So this is not well established yet, but you have to keep this in mind also. But in general, the costs of doing that is not supposed to be higher, because you can manipulate those embryos in an easy way. The big cost, I think, for me, the big cost of this is to do the research to find the right targets to be edited. This will take time and money and funds. Not the laboratory by itself, and or even the royalties. So I wouldn't say that, well, if you want to have a genome edited, so tomorrow you can have this. In that case, you can have just one animal, two animals, not a herd, this will take more time. But I think it's worth it to think about that. That's we have to use this tool to improve your breeds, some specific breeds, but this is not one thing to do in one day from another.
Okay, are you satisfied with that?
Let me explain that question. Answer.
Okay,
Yes.
Your mic.
Yes, Chijindo, Professor, let me just explain the way the Nigerians will understand the question. She has been asking, what is the profitability, or how is it possible that if you take money to establish those facilities that can fetch money? But we want to let her know, she's a youngster, just coming up. There are two kinds of research done in Nigeria here and elsewhere: commissioned research and non-commissioned research. In commissioned research, maybe a company or organization that has been approved to patent many discoveries can commission for this kind of work to be done. And as soon as the findings and the work, the product has been made, they will now multiply it. Just the way AstraZeneca was manufactured by the Oxford University. But they took it to an Indian company in India where they're now producing for the whole world that has a patent for royalty for the production. And that's why it is reaching the whole world. England cannot do it. The Oxford University cannot do it. The non-commissioned research is individual research any of us can do. When you have developed a marvelous product like that, all you need to do is to let the agency respond like NAFDA. Let NAFDA know. They can now seek for patenting for someone to give a patent for the mass production. No research is a profitable venture at all. You don't embark in research in order to make money. But when you make discovery, then look for a body that will buy off your product and pay you, be paying you royalties. Do you understand that?
QED. Thank you very much.
We'll take on one more question.
Please write it down.
I'm not writing everything. You have to brain mining.
Okay, I need to be gender sensitive. I need to be gender sensitive. Okay, let me give her the bottom of the pot. Please come, gentlemen. I'm reserving the bottom of the pot for you.
You should.
This is the lady there.
No, please, your mic is there. You can.
Good afternoon. My question is actually on this genetic improvement. For us to have very good production, there are two factors: the genetic aspect of the animal as well as the environment. And when we talk about the environment, we look into factors such as our production system, our feeding, and the nutrient status of those ingredients that we're going to feed to the animals. We also are talking about the health aspect of the animal, the health status of the animal. Now, in our own local situation here, we have not actually dealt with issues of health, production system, and availability of nutrients. And we are jumping into the genetic aspect of the animal. Are we actually not running when we have not learned how to walk? So shouldn't we look at how to improve? Because we have a lot of problems with even our production system. Imagine a situation whereby you are learning, you are trying to improve the genetic of the animal, when most of, if you take our cattle, for instance, most of them are run across the country, depending on the season. So I think that in as much as it is good to look at the genetic improvement, we should also take a look at how the environment affects the productivity. Thank you.
Thank you. That's more of a comment than a question.
Yeah.
Okay. Thank you very much for that comment. It's a brilliant one. Can we have you, man?
Okay. Thank you very much. Mine is a general comment arising from what, or the question Chijindo raised. I'm Gloria Obio. I direct environmental biotechnology and bioconservation of NAFDA. I want to place it on record that science and research is serious business. Some people didn't believe or agree with her when she asked of profitability. Science, I repeat, science and research generally is serious business. And there is a lot of money, I keep telling my younger colleagues, but you must be patient to make the money out of science and research. The money or business aspects will not yield the dividend until you take your product to the market. So whatever you are doing, whatever aspect of research, you must focus on commercialization. The moment your product gets to the market, whether it's commissioned research or non-commissioned research, translational research, or basic research, you are out there to make money. But what we are yearning for is for government to reduce the gap, to come to play, to reduce the margin between the time of innovation and the time the product gets to market. It's a very huge, large process, which is very windy, and you cannot predict it. But government can come in through what we call lean commercialization, which Chinese are using to bridge the gap, so that we fast track and leapfrog from where we are. All I'm saying is that it is profitable. Every research is profitable, but you must patent your work and then talk of commercializing it through either leasing out or non-exclusive license. Thank you.
Thank you for that wonderful comment. I just take the summary. She said research is profitable. In other words, it has the ability to generate profit. And number two, I deduce that what you're saying, it's not a short-term thing. And so you need to be sustained by something. There's a proverb in my local language that says that if you want to eat the meat from a fatty animal, then you must be patient. Eat something first, because it will not be ready in time, because the fat will keep killing the fire when you are roasting it. So you must eat something first before the roasted meat is ready. So that is that. Professor, you want to give us your final thoughts?
First of all, to thank you for this opportunity, and I appreciate all the comments and questions. One thing that's interesting to say that about the breeding programs, about 20, 30 years ago, our breeders were concerned about only about milk and beef production. So for them, breeding program, genetic improvement was only for milk and production, to increase milk production. But now some of them, and our research too, we are now aware that when we think in breeding, it's not for milk production, but also to adapt the animals to the environment. So we have to consider, as the colleague said, we have to consider the environment. So for that, so now you can use this. We are selecting animals that are more adapted. It does not mean that the animal has to be the high producer, but it's a well-adapted animal. So that's one thing. This my last comment about my presentation. But thank you very much for again for this opportunity, and I hope to maybe to have opportunity to meet you in person. That since we, despite this technology Zoom, it's very good one. You know, I miss much this kind of in-person meeting. So thank you very much for this opportunity.
Yes, Prof. Thank you very much. And the power vested upon me. I'll take just this one, please. I have the veto for now. Please, can I? Yes, the questions are documented. Oh, now they are becoming two. What do we do? I'll take you, sir. Prof. No, I'll take you, Prof.
Mine is just very short. And it's a comment made by the last but one speaker. We know that we can improve productivity through means, genetically, or you improve the non-genetic factors, which you call environment. But it's like you want to send those of us in genetics into bed earlier. And that is why I cannot just keep quiet. Please, genetic improvement has a lot of advantages over the improvement of non-genetic factors. And the main one is the fact that whatever improvements you record genetically can be transferred from generation to generation
Whatever improvement you record, improving the non-genetic factors, the feeding, the healthcare, the production practices, cannot be transferred. You have to repeat the same thing over and over. So that is why we place emphasis.
Every day.
And yes, that is why genetic improvement, expensive though, is like capital investments. But the other one you do is like, I mean, you are just having a savings account. So please, don't send us into sleep earlier.
Or to early retirement.
I know, yeah, please,
Thank you, Prof.
Let us appreciate the geneticists. It's one of the problems we are having in third world countries, not only in Nigeria. Geneticists should be at the center of improvement in animal performance. But for one reason or the other, it is not so. This is an opportunity for us to correct that.
A beautiful round of applause for our professor. You are well appreciated. That's why you are here. This one, if I don't take it, I am risking my license. So you know what I mean? My veterinary license. So let me just take it. Forgive me. Sir, 30 seconds.
Okay. Actually, mine is just to add that the issue here is that of technology. I think let's not forget the fact that technology, having a technology is very, very vital for the survival of a nation. So whatever technology we are acquiring, let's not see it as if, okay, it should be in terms of Naira and Kobo. No. The technology we are able to have today is going to be for the improvement of life for incoming generations. You look at currently now, transgenesis, recombinant DNA technology are now gene editing. Now let's assess